Scholars, I am the speaker of this conference. Load quality analysis and forecasting for power data set on cloud platform. My name is Xiang. The report of this meeting is divided into the following four modules: research background, analysis and improvement of power data, data production and summary. The first model of the research background is normalized. The model introduces the development of the energy internet cloud platform, smart grid, and the shortage of power data collected at the present. Under the background of energy internet and the new electronical reform, the power technology respected by smart grid is constantly integration with information technology respected by cloud computing and big data, challenging the way of production and operation of electronical power enterprise. Through the combination of cloud platform and big data. On the one hand, the established big data management system can not only coordinate the coordinate the data management among the enterprise, but also use the exciting data processing technology to clean the process the relevant data, ensure the quality of data, and improve the efficiency of using data. On the other hand, cloud platform technology can be used to share various data and improve data utilization at the same time, with the continuous promotion of the constitution of smart grid, the power custom information system as an important way of power consumption side information acquisition and power consumption control produce more and more big data. In the process of power data acquisition, the operation data of one power system can be collected by using intelligent equipment such as intelligent economic electricity meter, so as to realize the accuracy and actuals in the data acquisition stage, and then systematically process and analyze the collected power data, so as to realize the timeless of data. Finally, combined with big data analysis and the power system model, the power grid operation can be diagnosed, optimized, and practiced, so as to provide the safe, reliable, economical, and efficient operation of power grid. In order to obtain accurate and perfect datasets, various scholars have collected and established different power datasets in the power business process management in the cloud platform big data management system. However, whether serious devices or power data system compared with the exciting public datasets, although the data they collected is more experimental targeted than the public datasets, their spanning accuracy is imperfect, and for the exciting forecasting models, they are not as universal as public datasets. Therefore, how to make efficient use of power data study is particularly important. The second mode is the analysis and improvement model of power data. The model analyzes and compares the functions of commonly used power datasets. Finally, the methods to improve quality of power data are summarized at present. The commonly used power datasets include IDD dataset, Blue dataset, and UKDATA dataset. IDD dataset provides high and low frequency household power data. The main advice of IEDD dataset is that its data is rich enough to adapt to model with a large network training. IEDD datasets are relevant clean compared with other datasets, and good results can be achieved without post-processing. The broad dataset provides high frequency household power data with a frequency of 20, and the dataset provides a list of events when the state of household applies changes. The advantage of blue dataset is that it provides the equivalent power data with time as, which is conducive to use in evaluation algorithm to confirm the uh, decoupling result. The UK datasets the UK dataset continues to of 4 years of electricity data for 6 UK households. The UK dataset provides high frequency household power data with a sweeping frequency of 16 and independent low frequency household power data. The advice of UK dataset is that it provides a long duration of data and can meet the needs of forecasting at different times of the year. The analysis shows that IEDD dataset, Blue dataset, and UK dataset have obvious differences in acquisition area, data acquisition frequency, and data volume. Therefore, a reasonable power dataset can not only analyze and formulate a reasonable management process in cloud platform data system, but also predict and plan the future time arrangement, serious evaluation, and process management. There are many ways to improve data quality. Academic generally considers data clean and data progress. For the perspective of data clean, implement data quality mainly from three angles: box method, mm, cost, constant method, and regression method. For the president of data processing method, implement data quality mainly from two agents: standardizations and normalizations. This is the data clean. The third mode is the data production mode. The mode introduces two common production modes, R mode and LSTM mode, and tests it on its own datasets. Finally, the production result of two modes are analyzed and compared. AM model is a typical time series model, which consists of three parts: AR model, AR model, MA model, and difference methods. Therefore, ARM is called the auto-receptive moving arrangement model. The overall process state of ARM model are as follows: check the standardizations of the data. If it is unsuitable, carry out difficult processing. White noise test is performed on stationary sequences. SCF function and PSF function are used to rank the sequences that meet the requirements, verify the accuracy of the model, use model protection, and predicate and analyze the data. LSTM network is a special type of iron which can learn long-term development information. Of course, LSTM and baseline iron are not very different in structure, but they use different functions to circuit the hidden state. LSTM can avoid the problem of long-term developments, and the central idea is cell state. The network consists of gates with various secretions. The creation of a door is completed by synchronic function and pointer modulation operation. Iron is a repetitive single natural network layer, while the repetitive model in LSTM consists of four inter, interactive layers, three single layers, and one tangent share, and interacts in a very special way. Through the combination of a protector, let's, let me show you the ARM, ARM model forecasting result and LSTM forecasting results. Through the combination of protection results, we can intuition see the effective combinations of two models, in which the emphasis is hour and ordinate is power. It can be seen from the result of two diagrams that ARM model has a series large and production offset is large in first 15 hours, while LSTM model has no series large and the offset is small in the first 15 hours. This also shows outstanding performance of LSTM model in single production model. At the same time, the paper also used two repetitive evaluation error standards to evaluate the production accuracy, named root mean square error and mean absolute deviations. It can be seen from the table that the LSTM model is lower than M model in all indexes, and the difference is large. LSTM performs better than M model in time cell production. Therefore, LSTM model has the highest production accuracy and the best performance, and can be better applied to production and analysis of data quality. The fourth model is the summary model. This model summarizes the process of big data data quality analysis of cloud platform, the shortcomings of acute power data, and the solution to this difficulty. The load data quality analysis of cloud platform big data can be divided into processing, evaluation, process decision and analysis, processing development and processing implementations. Starting with the process implementation, the paper analyzes the problem related to process data quality in process implementation management and the way to improve data quality. Taking the power business processing execution management as an example, this paper analyzes the shortcomings of the existing power datasets. In terms of data scale, the mainstream power datasets can provide large-scale household power data, but in the large-scale data, the data classification is not very unbalanced, which will seriously lead to the accuracy of the experiments. In terms of data frequency, high-frequency data is poor to data redundancies, while low-frequency data has a long spanning period. and slow data collection. In terms of data declaration and discrepancy, they are differences, and the major datasets are not undefined with each other. Aim at this problem. The most to improve the data quality are summarized, then starting from the data load itself, and the final data quality is improved by two methods: data clean and data progress, and data pre progressive. In cloud platform data management, data quality cannot be ignored. Therefore, how to effectively process the data sets to be used in business progress and how to improve the data quality of this data still need to be explored and discovered. The above is all the contents of report of this meeting. Thanks for your listening.